Hello everyone, I am B. Dikshita from 3rd year ECE from Sri Venkateswara Engineering College. As a part of internship by MRZ, we have done a project on embedded systems, that is car black box. My teammates are Nikita and Guna Chamundeshwari. These are the contents that we are discussed in this presentation. Those are Introduction to C, Introduction to Embedded Systems, How to Choose Embedded Systems, Microcontroller versus Microprocessor, LED, Syncing and Sourcing Circuit, Uses of Embedded Systems, Tactile Switches, Polling, PIC 16F877A Microcontroller, CLCD, Matrix Keypad, and ISR, timers, potentiometer, double EEPROM, real-time clock, car black box, and structure of car black box, its features, an internal diagram, microcontroller, required softwares, and last, project implementation. Let's begin with Introduction to C. C is a general-purpose programming language created by Dennis Ritchie at the Bell Laboratories in the year 1972. It is a very popular language. Despite being old, C is strongly associated with Unix as it was developed to write the Unix operating systems. Let's see what are the features of C. C is a portable language and it is simple, it is powerful and fast, efficient, modularity and compiler based, platform dependent, uses of pointer. It is a middle level language, it is structure oriented language and it is case sensitive and it is syntax based. Keywords. Keywords are the built-in words in C language. We have 32 keywords in C language. Those are auto, break, case, char, continue, do, default, const, double, else, enum, extern, for, if, goto, float, int, long, register, return, signed, static, size of, short, struct, switch, type def, union, void, while, volatile and undesigned. What is embedded systems? An embedded system is a combination of computer hardware and software designed for a specific function. Embedded system may also function within a larger system. The systems can be programmable or have a fixed functionality. The purpose of embedded systems is to control a specific function within a device. They are usually designed to only perform this function repeatedly, but more developed embedded systems can control entire operating systems. We have various types of embedded systems. Those are standalone, real-time, networked and mobile system. What is standalone system? Standalone system itself has two different types. Those are slave system and independent system. Slave system, it is not that much intelligent through embedded system because it depends on external devices. For example, semi-automatic washing machine. Next, independent system. This system can take action by their own. For example, Google cars. Next, real-time system. These systems are time-bound system which will take action on a specified time. Failures in the system are not acceptable. We have types in real-time system. Those are hard real-time, firm real-time and soft real-time. For example of this real-time system is airbag system. Next, network system. The system which are connected to the network. Example is home security system. Next, mobile system. The system which are movable are called as mobile system. We can see those are robots. This is the software of embedded systems which contains digital to analog converter, analog to digital converter and sensors, human interfaces, diagnostic port, FPGA and memory. How to choose best embedded system? A system which consumes less power is one of the best embedded system and it must have low cost and high efficiency, efficient use of processing power and reliability, efficient use of memory. Next, what is microcontroller and microprocessor? An integrated circuit which is capable of being programmed to perform a specified task, and it has a design restriction such as memory size, input-output capabilities, peripheral functions, etc. We must choose a best microcontroller based on these features like its applications, its performance and its price, availability of tools and special capabilities. Next, What is microcontroller and versus microprocessor? Microcontroller. All components will be in a single chip, less flexible and less design complexity. Whereas in microprocessor, all components are assembled separately and it is more flexible than microcontroller and design complexity is more. LED, light emitting diode. Simplest device used in most on the embedded applications as feedback. Low energy consumptions, longer life, smaller size, faster switching make it usable in wide applications. Syncing and sourcing circuit, and it has current sourcing and current syncing. Current flows out of device and herein current flows into device. Next, uses of embedded systems. As embedded systems are used in various applications like vehicles, telecommunications, etc., we have created car black box using embedded systems. Here we can see various applications like manufacturing equipment, motion sensors, cars and vehicles, medical devices, telecommunication equipment, gaming consoles, audiovisual equipment, and domestic appliances. These are the most required and must required softwares to implement this project. The first one is MPLab IDE. MPLab IDE is a free integrated tool set for the development of embedded applications on microchips, PIC and DSPIC microcontrollers. XC8 compiler. MPLab X, a free integrated development IDE from Microchip for programming their PIC microcontrollers. XC8 is a C compiler from Microchip for 8-bit PICs. Both programs run on Windows, Mac OS and Linux. And the first and last thing, but it is the most thing, is PicSimLab. PicSimLab have integration with MPLabX Arduino IDE for programming the board's microcontrollers. As the purpose of PicSimLab is to emulate real hardware, it does not have any source coding editing support. So these are the contents that we can found in PicSimLab. Those are PIC 16F877A microcontroller, 16x2 CLCD, digital keypad, potentiometer, timer, double EEPROM and real-time clock. From this, my friend Gunachamundeshwari will explain.
Hello everyone, I am Gunachamundeshwari. Currently I am pursuing third year BTech from Sri Venkateshwara Engineering College in the branch of Electronics and Communications. So coming back to the project, tactile switches. Tactile switch is a switch whose operation is perceptible by touch. This switch is used to select the mode of operation and to enter the temperature and to enter in time period in our project. This switch will provide a bouncing effect when a switch is pressed. Provides a simple and cheap interface. Some common application of tactile switches are HMI, mobile phones, computer, mouse, etc. These are the some images of the tactile switches. And coming back to polling, it is the process where the computer or controlling device waits for an external device to check the readiness or state, often with lower level hardware. So some disadvantages of polling are loss of events may occur during polling, poor response, less power management. And we have seen about the interrupts. Let us see the classification in interrupts. Interrupts are classified into two parts, hardware interrupts and software interrupts. Hardware interrupts are again classified into non-maskable and maskable, whereas maskable interrupts are also classified as external interrupts and internal interrupts. PIC 16F877A microcontroller is given in the image and it consists of RS232 LEDs, buzzer, digital keypad, SSDs, matrix keypad, CLCD, GPIO, EEPROM, temperature sensor and analog to digital converter. So it consists of CLCD. CLCD stands for character crystal liquid display. In PicSimLab we have two types of displays, 16:2 display and 16:4 display. Matrix keypad. This is a keypad in which number of tactile switches are connected in a row and column. These are the most commonly used in digital lockers, telephones, calculators, etc. So interrupt. In simple words, interrupt is defined as stopping the present work and executing other work and returning back to the same work. ISR stands for Interrupt Service Routine. An interrupt service routine is a software that which invokes the response of an interrupt. So ISR examines an interrupt and determines how to handle, executes the handling, and then returns a logical interrupt value. This is how the ISR works. The sequential execution of a program is given, and the hardware interrupt caught here. Sequential execution of program picks up when it left. This is the program. Program controller jumps to ISR, and this is the ISR. Program control returns to interrupted program. So ISR executes to completion. Timers. Timers is a very important application in any embedded system, which is a default peripheral which maintains the timing of an operation in sync with the system clock or an external clock. Timer is a software designed to count time intervals between events. Potentiometer. The potentiometer serves as an analog input to the microcontroller. Potentiometer is a peripheral which can regulate its speed. Analog to digital converter is used to convert signal from analog to digital, and ADC converter modules have 5 inputs for the 28 pin devices and 8 for the 40 to 44 pin devices. The conversion of analog input signal results in a corresponding 10-bit digital number. So the resolution of analog to digital converters are with if an 8-bit ADC consists of 0 to 255, 10-bit it consists of 0 to 1023, and 12-bit consists of 0 to 4095. EEPROM. EEPROM stands for Electrically Erasable Programmable Read-Only Memory. EEPROM is a PROM that can be erased and reprogrammed using an electrical charge. This size and component of storage depends upon the requirements. Modern controllers has built-in data storage, EEPROM and data flash. There are 3 memory blocks in each of the microcontroller devices. The current microcontroller we are using in this project, which is PIC 16F887A, have 8K words, 14 bits of flash memory. These devices has 128 or 256 bytes of data EEPROM with an address range of 00H to FFH, which is in hexadecimal number system. The EEPROM data memory allows single byte read and write. The flash program memory allows single word reads and 4-word block writes. Real-time clock. A real-time clock or RTC is a computer clock, usually in the form of integrated circuit that is solely built for keeping time. Naturally, it counts hours, minutes, seconds, months, days, and years. RTCs can be found running in personal computers, embedded systems and servers, and are present in any electronic device that may require accurate timekeeping. Benefits of RTC includes RTC ICs have proved to be more precise than other methods like programming the timer of the microcontroller. It frees the main system from time critical tasks. It has low power consumption and improved frequency stability. So this is our project car black box. Let's see what is meant by car black box. A car black box is either physically installed in the car or downloaded as a smartphone app. It links to a GPS that measures and records the vehicle speed, location and distance traveled, driving frequency and time of the day in motion. After a car is met with an accident, it is important to determine how crash was caused and what are the factors influenced the crash. This information helps prove liability after an accident, which makes it easier for an injured parties to fight for the compensation they are rightfully owed. A black box can be instrumental in this process and can effectively help with an investigation involving car accident liability. If you are involved in an accident, make sure you know how a black box system can help you. So these are the things can be done in a car: vehicle speed, airbag development times, braking activity, seat belt use, steering angles, throttle position, vehicle tilt, fuel monitoring. These are the factors to be considered while an accident is done. Structure of black box. So this is the black box and it is placed in the car. So features of the black box. It is constructed with steel armor plate. It has a thick slab of paraffin. It can be operated in between -55 to +70 degrees centigrade. It can carry a minimum 25 hours of flight data. Internal structure of black box. The car black box consists of engine speed, vehicle speed, throttle position, braking status, and the force impact, airbag deployment, safety belt usage, and steering input. Microcontroller. So let's see what is meant by a microcontroller. Microcontroller is a compressed microcomputer manufactured to control the functions of embedded systems in office machines, robots, home appliances, motor vehicles, and a number of other gadgets. A microcontroller is comprises components like memory, peripherals, and most importantly a processor. We have used PIC16F877A microcontroller in this project. It is used in many digital electronic circuits like remote sensors, security and safety devices, home automation, and many industrial instruments. This is the microcontroller we have used in this project, car black box. This is how it looks. And the project implementation. After loading the code in PiximLab, we can see the initial screen with time, event, and speed. The time will be matched with the current time. To record the data usage, we have to use these keys. RB0 for reading collision, and RB1 key for reading gears, and RB2 for reading reverse gears. To see the recorded data, we have to enter the password by clicking the RB3 or RB4 keys. After clicking them, we can see the screen as view log and clear log. By clicking the view log option, we can see the recorded data in the below format. It is with the serial numbers and time and the event we have recorded and with the speed. So let's move on to the project. The project implementation will be explained by my friend K. Nikita.
Hello everyone, I am K. Nikita from 3rd year ECE department. I am going to explain our project Car Black Box.
This is the project and the type of board is PicGenius and microcontroller is PIC16F877A. Let me load the file once again. Here, this is the default dashboard with time, event and speed. From RB0 to RB5 are tactile switches. These are the LEDs, these are potentiometers, this is W probe and this is the microcontroller. This is RTC and this is reset button. Now, by clicking RB0, it records collision. So, event is C. RB1, normal gear, reverse gear, gear 1, gear 2, 3 and 4. Similarly, by clicking RB2, we can record the reverse gears. G3, G2, G1, GR and GL. Now, let us view the events. To that, we can click any of these two buttons. I have clicked RB3 and password is RB4, RB3, RB4 and RB3. We can view this screen like this, view log and clear log. Now I want view log, so that I have to select OK by using RB5 button. Now this is the serial number, time, event and speed. We can increase by using RB4, 1, 2, 3, 4 and 5. We can decrease it using RB3. Now let us reset it and clear the blocks. To clear the blocks, we have to enter the password once again. And you should select RB4 and now OK. So logs cleared successfully. Now let us change the password. To change the password, we have to click RB4 once again and click on RB5. Now we will create a new password, that is RB3, RB4, RB3 and RB3, 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 RB3. Now password changed successfully. This is our project. Thank you for giving me this opportunity.